Good morning, everyone, and welcome to the Progressive Web App Summit. My name is Ire Aderinokun, and I'm the co-founder and I lead the front-end team at Bitcoins, which is a cryptocurrency exchange for Africans. So I'm really excited to be kicking off this event today. Like I'm sure a lot of you are, I'm really excited about what progressive web apps have done for the web. So today I'm going to be talking to you about how progressive web apps have developed over the past 5 years and what it's like to develop and use them today. So before the concept of progressive web apps was introduced, web applications, if you could even really call them that, were really getting their butts kicked by native applications, particularly on mobile. The web in general was less capable than native applications, so they lacked the critical features that made mobile apps really engaging. So things like being integrated to the device and personalization and push notifications. And critically, websites were not available offline, and this just severely limited how and when they could be used. So even if a mobile application wasn't all that usable without connection, it could still at least be opened and interacted with to some extent, and this is still like a better experience than getting this type of message. Websites were also harder to access, so native applications had the advantage of having dedicated visual space on the device and were just one click away from full immersion. But with websites, they're all lumped under the same app, the browser. So if I wanted to send a tweet via a website, it was going to require a lot more steps than the 2 or 3 it would take on a mobile application. And I really like how this was visualized in this graph from the web.dev blog. So native apps are really great in terms of capabilities, but they're poor in reach since they're closed off to a certain ecosystem. And web apps, on the other hand, have the benefit of reach, but are lacking the capabilities. So of course, the question is, what can fill this gap in terms of having both the reach and the capabilities? And of course, the answer was progressive web apps. So they're defined by this exact intersection. They use modern web capabilities to deliver a user experience similar to native applications. And they do this while maintaining the main benefit of the web, its reach and low barrier to entry. Essentially, progressive web apps are the best of both worlds. And there are 3 core features that make a progressive web app. So it needs to be capable, reliable, and installable. And by capable, we mean that progressive web apps need to take advantage of the modern APIs, which put it on the same footing as native applications. So for example, getting push notifications using the web push API, or getting access to the files with the file system API, or even just taking advantage of new web standards such as WebAssembly. By reliable, we mean that a progressive web app should feel fast and dependable regardless of network connection. So in essence, nothing should slow down a progressive web app. And in fact, progressive web apps should take an offline first approach. So they should think of connection to the network as more of an enhancement and provide a base experience that doesn't depend on being online. And this is probably the most drastic difference between traditional websites and progressive web apps, since the former were essentially defined by their access to the internet. And even when online, progressive web apps should feel fast and resilient. So this means loading as quickly as possible, responding to user input seamlessly, and being accessible across devices. Finally, progressive web apps should be installable, meaning that they can be installed to the device as a standalone application and used outside of the browser. And they should also be integrated within the system like other native applications. So for example, being accessible by an icon on the home screen or within the app drawer, or basically wherever native applications live on that device. And tying all of these 3 concepts together is progressive enhancement. So progressive web apps are so called because at their core, they're applications built with progressive enhancement in mind, meaning that none of the extra features should be implemented at the detriment to having that core standard website experience that we've always had. Unfortunately, when the concept of progressive web apps was introduced, they didn't exactly live up to that dream quite yet. In order for progressive web apps to really rival native applications, there are some capabilities that are really critical to have that were just missing. So for example, push notifications, and the push API was just For example, push notifications. This was just starting to be implemented in Chrome alone, basically. And features like background fetch, so the app still has the concept of existing and working without the page being actively used or even open. This wasn't a thing at all. And it was a similar story for APIs like the file system access API. So web apps could actually be like integrated into the device. So in essence, we had to do a lot of this. And this is obviously still a valid and recommended way to write our code for the purpose of progressive enhancement. But the problem was that most of the time it was like the same old boring code that ended up being used. And that just meant it was much harder to justify spending the time developing the really awesome thing if it was just hardly ever going to be used in real world cases. And service workers, and by extension, the offline first approach, wasn't totally ready yet either. So like the other capabilities I mentioned, service worker wasn't the support for service worker wasn't widespread enough to be used reliably. But arguably, the main issue with service workers was actually like how difficult they were to use. And I'm sure we can all relate with this person's predicament of being stuck with a service worker that would just basically never update. And compatibility with frameworks was another major issue. So a lot of progressive web app experiments ended up being complete rebuilds without frameworks because there wasn't really a straightforward way or known way to like make progressive web apps with the tools and frameworks we were already using. The install experience for progressive web apps, so at the home screen, wasn't really the same as installing in native applications. As developers, we had very little control over when a user would be prompted to add an app to their home screen. There were basically these three requirements before a progressive web app would even be eligible. So we needed like a manifest file, we needed a service worker, and we needed this visit frequency heuristics thing, which is just as vague as it sounds, but it essentially means that the banner would only show up after the browser thought the user had visited or engaged with the domain enough to show an interest in actually like installing the application. And it is understandable why these barriers were put up, because we didn't all of a sudden just want all spam websites to just like start popping up banners everywhere. But the reality is just that add to home screen wasn't the same as installing. And to top it all off, the support was actually pretty dire too. So across the board, progressive web apps couldn't really be considered capable, reliable, or installable. But here we are 5 years on. So what is it like developing and using progressive web apps today? Well, we've seen progressive web apps being used in a lot more cases today than ever before. So basically every major application now has a progressive web app version. In fact, an estimated 1.5 million websites are considered to be installable as progressive web apps, and there's tens of millions of installations happening every single month on Chrome for Android alone. We're also really close to 20% of all page loads in Chrome being controlled by service workers. And this is really huge because it means that service worker and offline websites are becoming more and more common. So how capable, reliable, and installable are progressive web apps today? So first, capable. And thanks to a project codenamed Project Fugu, progressive web apps are definitely a lot more capable today. So this is an initiative which started with the Chromium team, but has now grown to be a collective project with contributions from like Microsoft, Intel, Samsung, and the core Google team. And it's basically an effort to close gaps in the web's capabilities by enabling new classes of applications to run on the web. So this means shipping a lot more web APIs quicker than ever before. And there's going to be a session from May later today all about Project Fugu. So what the process is for shipping new features and how to be more involved in contributing feedback and all of that good stuff. But what exactly has been shipped in this last 5 years, and both under Project Fugu and outside of it? So like what type of web applications can we build today? So to start off with, we can build a lot more engaging progressive web apps today. And a major part of making web applications engaging is having reliable push notifications. And as we have probably all experienced, most progressive web apps have this feature implemented. And the feature of push notifications is controlled by two main APIs. So we have the web notifications API, which controls like the permission and the display of a notification message. And then the push API, which allows the browser to like receive push messages from a server. And in terms of support, both of these APIs are relatively well supported. The only major market missing is iOS Safari, which we'll see is a bit of a theme, and it is quite disappointing because it is like such a big market, and there aren't really any signs that Apple is going to implement it anytime soon. The only real solution to this, if you want notifications on iOS, is to basically wrap your Progressive Web App in a native iOS app, which sort of defeats the purpose. And we have a similar story for the push API. So the support is essentially the same. I added this asterisk to desktop Safari because it does support a form of push notifications, but it's just not the web standard. It's a custom implementation. To go along with push notifications, Progressive Web Apps now also have app badge icons that let you know when you have an unread notification. So this is available for both desktop Progressive Web Apps and mobile. And on mobile, you can even get a preview of the notification by long pressing on the badge icon. And the API behind this is the app badging API. And this is actually one of my favorites because it's just incredibly simple. It's just these two methods, setup badge and clear app badge, is like amazing. And this is a pretty new API, but already has like really good adoption so far. And Mozilla, which is the last major browser besides Safari that's yet to adopt it, has so far marked it as a feature worth prototyping. So we hope to see this implemented in Firefox soon. So Progressive Web Apps today can also have real interaction with other applications installed on the device. So we can now share data both from and to Progressive Web Apps. So for example, in the Twitter app, you can share a tweet to other applications the same way you would do like from any other native mobile application. And this is enabled by the Web Share API. And on the flip side, a Progressive Web App can be a target of shares from other applications. So we can be on the website for the Progressive Web App Summit and share that link to the Twitter Progressive Web App, and it will basically accept that and create a new tweet based on that data. And this is achieved using the Web Share Target API. So in our manifest file, we can define like what types of data our Progressive Web App can accept and what to do when that data is received. And the support for the Web Share API, so sharing data from our Progressive Web App to other apps, is pretty good. And for Web Share Target, so the other way around, the support isn't really as clear. We know for sure it is supported by Chrome and Edge, and it's not supported in Safari yet, but not so sure about other browsers at the moment. In terms of capabilities, perhaps the most impressive is that Progressive Web Apps today can have like real access to the device. And this can be from something as small as like detecting which color scheme the user prefers with the prefers color scheme media query, or being able to access the contacts on the device with the contact picker. So this is an app that just demos how that contact picker works. So we can select which fields we want to extract from the contact book to display. Or even more impressively, Progressive Web App can now read and write the files on the device. So a great example of this is Photopea, which is a Photoshop style application that runs entirely in the browser, which would have been unimaginable just like 5 years before. So we can read a file locally on the device, edit it, and save back to it all from the Progressive Web App. And these APIs are also pretty well supported. So the prefers color scheme media query has the most support. And the contacts API, which is only available on mobile browsers, is also pretty well supported with the exception of Firefox and iOS Safari. And the file system access API has the most limited support, which is to be expected since it was only released like in the past year or so, and it's definitely a lot more complex. Finally, Progressive Web Apps can also now exist and work without the user being active in the browser. So a classic example of this is displaying the status of media that's playing in the background within the system UI. And this is made possible with the Media Session API, which lets us define metadata about a piece of media that's being played. and has pretty significant support across the major browsers. We can also have more long-running tasks running in the background, even if the user actually closes the browser tab that initiated the task. So in this example, we can see how the download of the latest episode of the HTTP 203 podcast still continues, even when I close the browser and even without the Progressive Web App itself actually being installed to the device. And this is made possible with the Background Fetch API. And this is an API that has been around a bit and is relatively well supported. But despite the support, it doesn't really seem to be used a lot. And I was actually hard pressed to find real world examples that actually use this, even though I could think of plenty real world sites that probably should be using it. And this is also a bit of a theme across a lot of these capabilities. For example, with the periodic background sync API, which what you can do with it is, as you might guess, perform sync tasks periodically in the background. And it's really useful for just keeping apps fresh and up to date. So even if the user hasn't opened the Progressive Web App up in a while, we can still be syncing things in the background and keeping the data fresh. And the support for this API, I feel, is significant enough for at least some major platforms to adopt, but the usage of the feature is still pretty slim. And it's basically a reminder that there's two parts to making progressive web apps more capable. So the browsers obviously first need to implement the features. And we can kind of see that they've already really done this, particularly when it comes to the browser teams involved in Project Fugu. But on the other side, developers need to also take advantage of the features and actually champion and implement them in the sites that we build. And obviously no shade to anyone here, because I'm obviously counting myself in this as well. There's just so much that we can do on the web that we collectively aren't really taking as much advantage of as we probably should. And I think a major reason for this is that we just haven't really caught up yet to what the web can do. And all these new capabilities sort of mean a shift in how we think about the web. And that definitely takes up, all these new capabilities mean a major shift in how we think about the web. And that definitely takes some time to get used to. So the APIs I've just mentioned are just a snapshot of what's available. If you're interested in what's been shipped and what's upcoming, I'd recommend you check out this Fugu Tracker website, which of course is also a progressive web app. And it just basically shows everything from what's been shipped to what's basically just an idea. And with all these APIs, it may be difficult to know what features make sense for your app. So in this session, Jason and Gerardo will provide a framework for thinking about progressive web app features and how to put together a roadmap that delivers incremental improvements that will benefit your users. So where are we with capabilities today? And as we've seen, a lot of progress has been made, and I think we're getting actually very close to feature parity with native applications. However, not all platforms have made progress equally. So looking at Android and Windows, I would say that we are getting close to feature parity, but with iOS, it's essentially not that different to how things were 5 years ago. And then another sort of drawback is that with the speed at which new features have launched over the past 5 years, the lack of adoption of these features has also become a problem in itself. But all in all, I think we can say that progressive web apps today are quite capable. So next, how reliable are progressive web apps today? And a major part of this question is service worker ready? And I'm really happy to say that the answer is yes. As you can see, we are in a much better position with support for service worker today than we were 5 years ago. So essentially every browser that is going to support service workers and should support them already does. We also have better tools for developing service workers. So most browsers now allow us to more easily see and debug the service worker and its lifecycle. And we have visibility into the different events that a service worker is tuned into, so we can record and simulate them. And this is just a demo app I created, and you can kind of see how the background sync event is recorded, so we can actually see exactly when it was triggered and dispatched. We even have a solution to the infamous problem of a service worker never updating, which of course is to skip the waiting stage entirely. But perhaps the most significant improvement to the experience of writing service worker code is the introduction of tools like Workbox. And this is a really great library which just makes interfacing with service worker so much easier. And they even provide like a set of recipes for the most common tasks, so you don't have to like start implementing everything from scratch. So we have recipes for things like caching static assets while keeping them updated in the background, or tracking Google Analytics even when a user is offline, or serving an offline page from the cache if there's no network. So compared to how this would be implemented without Workbox, this is like a much cleaner and easier solution. Additionally, we now have much better support for building progressive web apps with the existing tools and frameworks that we already use. So every major framework now has some form of support for progressive web apps and offline first. So with Angular, we have like a guide on how to implement the app shell. We have similar guides for React and Vue as well. So thanks to all these improvements, we can create truly offline first progressive web apps today. And we're already seeing these applications out in the wild. So Twitter is a really great example of this. Most of the UI is able to load even while a user is offline, and there's a clear message as to why the content hasn't fully loaded. We see a similar example in the recently launched Microsoft OneDrive progressive web app. So again, besides the actual content, the app itself is able to load, and we can like click around the various pages. But besides just loading the main like UI app shell, which I'll talk a bit more about soon, we can use various storage APIs to actually save some content. So instead of just showing an offline message, we can actually serve cached content so a user could still interact with the site in much the same way they would if they were actually connected to the internet. So I do this on my blog, Bits of Code. If you, while you're online, you see an article that you like, you can actually bookmark it to be available offline. And then when you're offline, you can actually just access the article in its entirety. Another great example of this is Airbnb. So besides their homepage being able to be loaded without internet access, they also are working on this offline arrival guide, which will actually show users all their check-in information, as you can see. So like directions, setup, and crucially, like how to connect to the Wi-Fi, and all of this is available like offline. And this is exactly the type of progressive web apps we can create using this offline first model. And in this session, Callie is going to be talking about how they created this offline arrival guide and their progressive web app. So this is made possible with the various APIs we now have for in-browser storage. So things like IndexedDB, which is more for like structured data, or local session storage, which is just for like strings or like keys and things like that, or cache storage, where you can actually just store entire pages. And you may think that you're limited in what you can achieve by making an application available offline, especially when it comes to security. But in this session, Jeroen will talk about how you can actually secure your progressive web app and still support offline functionality. Beyond being able to work offline, progressive web apps need to be fast. And to load as quickly as possible, the recommended approach is to use the app shell model. And the way this model works is that the app shell, which is the minimal HTML, CSS, and JavaScript that's required to power the UI, is kept in cache. And this can be loaded instantly since it doesn't actually require access to the network. And then the main content of the page could be loaded either from the network or from local storage, basically as needed. So going back to Twitter again, we can see how the various parts of their UI loads incrementally. So we have the app shell, so pretty much the same parts of the page that load when a user is offline, that loads essentially instantly. And then the rest of the page builds in incrementally. And that's actually like the main Twitter website, which they actually converted to a progressive web app relatively recently after they saw incredible results from the light progressive web app that they launched back in 2017. Because from that experiment, they saw like a 65% increase in pages per session. They saw a 75% increase in tweets sent and a 20% decrease in bounce rates. In fact, the engineering lead of the project marveled that the web app had similar performance to their native app, but with less than 3% of the device storage. Another progressive web app experiment that showed amazing results was Tinder. So by converting their website to a progressive web app, they were able to deliver the core experience that the native applications did, but with just 10% of the data. And these are just a couple of examples, but there are literally dozens of stories of performance improvements that companies have seen from implementing progressive web apps. And in this session, Carl, Kinza, and Steve will talk more in depth about the performance of progressive web apps and, more importantly, how to approach it from a progressive enhancement point of view. And speed isn't the only benefit of the web. So progressive web apps, like websites in general, benefit from being more accessible. And this is because the web already has a gold accessibility standard, so the Web Content Accessibility Guidelines. And although the various mobile platforms have developed their own standards for accessibility, the web standard is still considered the most mature. So very often, by building a progressive web app, you're actually just building a more accessible application. And Pinterest saw this when they implemented their progressive web app. So in addition to all the great performance improvements, they noticed that the progressive web app was more accessible. It actually ended up being their first ever platform to support right-to-left languages. And in this session, Leonie will be talking about what you can do to ensure your whole progressive web app experience is accessible. So from load to install and beyond. So in terms of reliability, I would say that progressive web apps are doing very well. The support for the tools needed, like Service Worker, are widespread enough that we can generally expect it to be supported for most of our users. And the experience of developing Service Workers has improved to the point where it's more accessible to more developers. And more so with new APIs, we can make progressive web apps faster at smaller package sizes, and all while maintaining the web's benefit of accessibility. So progressive web apps today are truly reliable. And finally, how installable are progressive web apps today? And first, support. So this is definitely looking a lot better than 5 years ago. Almost all major browsers, particularly on mobile, have the support for this feature or are working towards it. And even iOS Safari does support this feature to some extent, just not like in web views. And although the level of install integration differs between browsers, they basically just all have some form of progressive web app install available. And the requirements for an app to be eligible for add to home screen or install have also changed a bit. So first, as before, we obviously need a web app manifest, and different browsers have different requirements for what's needed in your web app manifest, but there's now like a ton of websites you can go to that will help generate this for you. Secondly, the domain must be secure, and this is necessary since progressive web apps will likely be using features that require handling of user data, as we've already seen with APIs like the File System Access API, but also it's just best practice for websites nowadays. And next, we need our service worker. So this isn't actually even a requirement in all browsers, but something you will likely have anyway. And one thing to note is that I believe from now or soon, Chrome requires that your service worker should also return a valid response in the fetch event, even while offline. So this is a move towards making sure that installable apps really act like installable apps and are also like reliable. And finally, we still sort of have this user engagement heuristic thing. It is still in documentation I could find, particularly in Chrome, but it doesn't seem to effectively mean that much anymore because in most cases, the add to home screen prompt is still displayed even on like a first visit to a progressive web app. So it's not something that will really get in your way. And more significantly, we now have much more control over the install flow instead of it something that's just wholly controlled by the browser. We can now detect if a progressive web app can be installed, so if it fulfills that criteria, using this new before install prompt event. We can even intercept that default browser pop-up from showing and save that prompt to be used later, so we can have a more customized install flow where we show our own messaging or prompt before the user actually installs. And then we can also detect after a progressive web app has been installed with this app install event. So we can now actually fully customize that whole like end-to-end install or onboarding experience. And we can see how this is being used already. So on TikTok, they have a banner that lets users know they can get the app on desktop just in the corner there. And then when a user clicks on that custom banner, then it does show that default install prompt, allowing the user to confirm and then actually install the app to their device. Another great example is Twitter. So they show this banner that users can interact with that makes the case for why to install the Progressive Web App. And this is sort of akin to having an app page in the App Store, but it's even better because it's more immersive. As a user, you're already using the application, and then you have that promotional material. And then once the app is installed, you can basically carry on with whatever you were doing before. So it pops up on the home screen and you can just tap it and be right back in the Progressive Web App. And once a Progressive Web App has been installed, we now have better control over the launch experience as well. And we can do this by customizing the splash screen and adding custom icon, background color, and text. And this is achieved with a few items in the web app manifest. And although it's quite limited now, more customization options to the splash screen are definitely going to be coming in the future. And installed Progressive Web Apps can also be launched via quick shortcuts from the icon on the home screen. So we can go directly to sending a tweet from the icon, the same way we can do with other native apps. And this is also achieved through the web app manifest. So there's a new shortcuts field where we can define basically an array of different actions that a user can take from the app icon. Another really cool thing that was just launched recently is that we can now set a Progressive Web App to be automatically launched when a user logs into their device. And this is achieved with this new Run on OS login API. There's basically so much we can do now to customize the install and launch of our Progressive Web Apps. And in this session, Under will be taking us through the current and upcoming web standards that will enable us to make beautiful launch experiences on every platform. So we are getting closer and closer to add to home screen really being equal to install. So although we are not at full parity yet, we're definitely seeing a lot of improvement. On Android, we now have a concept of web APKs, and this is essentially a native Android application package that's created entirely from a Progressive Web App, and it's actually done automatically. So when a user clicks the add to home screen or install, so it actually doesn't really require anything extra from us as developers of the Progressive Web Apps. It's just done completely behind the scenes. And we get a lot of out of a package or PWA being packaged as a web APK. So the app shows up in the app drawer like any other native application. It has an app info page the same way other applications do. So there's a centralized and more standardized way to handle settings. We also have intent filters, which allows links from the website domain to be open in the application instead of the browser. So with web APKs, our Progressive Web App is very close to being treated like any other Android application. Going further, we can now actually package and publish our Progressive Web Apps directly on app stores as native applications, which starts to get a bit weird if you think about it too hard. In 2018, Microsoft was actually the first platform to allow for this, and they also created this awesome site that actually just helps you package your Progressive Web App to be submitted to the various stores that now accept them. So all you need is a URL to your Progressive Web App, and you can get packages for Windows, Android, and Samsung all in one place. And in this session, Micah will be sharing his experience of launching the Be Funky Progressive Web App onto the Google Play Store. So from the experience bundling it for release to integrating with Play payments as well. And another thing I'd like to mention is this concept of TWAs. And trusted web activities are a way to open a Progressive Web App from an Android application using a protocol based on custom tabs. So they're sort of like a web view, but a web view that's intended to only load a domain that you own and control, meaning that special access can be granted. And if you're interested in checking that out, I'd suggest you look into this library called Bubble Wrap, which is designed for front-end developers to launch their PWAs as TWAs. But you may be wondering what the use case of PWAs are. And I think there's basically two scenarios in which it could be used. So the main use case, I think, is if you already have an Android application, but you maybe wanted to move some dedicated pages to a progressive web app to get certain benefits. So maybe you have like an FAQ page of your app that's updated frequently. This could be converted to a TWA. Or you might want to go the other way. So you already have a fully fledged progressive web app, but your app requires some particular feature that's currently only available on Android. So you could do it this way, where most of your app is the progressive web app or the trusted web activity, and then one or two views are like native Android code. Basically, a trusted web activity is just a useful combination of these technologies. So you can choose which portions of your app need to be a progressive web app versus a native Android application. And it's just a reminder that the web and mobile technologies don't need to be antagonistic, and they can actually exist together, and we as developers can decide what technology should be used where. I really like how the Microsoft Edge team put it in their article announcing progressive web apps on the Microsoft Store. So when asked if it's recommended to go with one or the other, their answer was that it's basically a false dichotomy. There are many factors that should be taken into account when deciding on if an application should be web-based or native-based. There's just no one right answer for all. At the end of the day, it just comes down to what your team needs and how they build. And we're going to have a really interesting session from Twitter tech leads Charlie and Marina on how they build their team and processes for web engineering at scale. So the roundup on installability. So progressive web apps have made a lot of progress on this front, particularly with the support for adding to home screen. And we also have a lot more control over the install and launch experience, and much deeper integration with the device. But like capabilities, not all platforms have made progress equally. But on a whole, I think we are in a really good position with how installable progressive web apps today. So what's next for progressive web apps? So where do we expect to be in, say, like another 5 years? And obviously, the goal is to get to a state where progressive web apps can be truly capable, reliable, and installable, even to the extent that they exceed native applications, whatever that means. And to get there, we do still need to make progress with capabilities. And there are a lot of features currently in the pipeline that are really interesting and should keep moving progressive web apps closer towards feature parity with native applications. For example, the file handling API, which is currently in Origin trial. And this is basically an addition to the file system access API, which, as we saw, lets us open local files from our progressive web app. But this API kind of lets us start from the file and lets our progressive web app be one of the options that the file can be opened with. Or the tabbed application mode, which is currently under developer trial. And this will allow our progressive web apps to have tabs within a window instead of just being one standalone window. And another really needed API is the one for install time permissions. And this will allow our PWAs to actually just request permission for all the access that they need at one point during the install flow, instead of everything being like piecemeal. And this is only under consideration, so it's still a little while away, but I'm really excited for it. And there's so many APIs in the pipeline, and these are just a few more that I'm really excited about and are currently in development or under consideration. But even if all of these features are launched, we also need to make sure that they're actually being used. So one of the main benefits of the web is that we're never actually forced to upgrade or update our websites whenever new APIs are introduced. So we can never really expect 100% adoption of something new. But it's also clear that a lot of features are being underutilized. And it is a bit like tongue-in-cheek to say that only 20% of page loads are controlled by service workers, because that is a really big deal. But with a lot of other amazing features, we're not even close to this number. And even with adoption from all websites, I think the main thing that really needs to be addressed over the next 5 years is the feature parity between the web on different platforms. So currently the web on Android and Windows is really like miles ahead of the web on iOS. And we need to be careful not to end up in a situation where the web suffers from the same issues as native applications. The reason progressive web apps are the best of both worlds is because they still have the reach of the web. So if there becomes a divide between how the web works depending on the platform, then progressive web apps become no different from native applications. So in order for progressive web apps to really be the best of both worlds, the web needs to be the same web everywhere. So lastly, to close out the summit, there's going to be a panel on the future of web apps. So with industry experts from Google, Microsoft, Intel, Samsung, and the W3C. So definitely don't miss that. So thank you and enjoy the summit.